Here's how to solve for impulse in physics. Anytime you have a question talking about the average force applied, or the duration of a collision, you're probably going to want to use this equation, which we call the impulse formula. Quick trick. If you ever forget this formula, you can always rederive it from Newton's second law, F equals ma. Here we rewrite the acceleration as the change in velocity over the change in time, and just move the delta t to the other side. The cool thing about impulse is it allows us to calculate the average force applied to an object in order to change its velocity. Such as in this question, where a 2-kilogram ball is thrown at a wall with a speed of 10 meters per second and bounces back at the same speed after being in contact with the wall for 20 milliseconds. Find the average force exerted on the ball from the wall. Here we can use our impulse formula to solve for the average force, F, by plugging in 2 for the mass and 20 milliseconds, or 0.02 seconds for delta t, since that's the duration of the collision. However, when determining delta v, we need to be careful and remember that since the velocity goes from a positive 10 to a negative 10 meters per second, the total change in velocity is actually negative 20. This gives us F equals negative 2,000 newtons, which makes sense because the force from the wall is opposite to the original direction of the ball. Now where impulse gets really cool is showing how the average force of a collision and the time duration of a collision are inversely proportional. What this means is that for the same object colliding and coming to a complete stop, if the time of the collision is greater, then the average force exerted during the collision will be less, and vice versa. This is also why modern-day cars look flimsy and are designed to crumple and break into many pieces in the event of a crash. Because the more time it takes to bend the weaker metal means the less average force felt by the driver. It turns out that the stronger all-steel cars from the past are actually less safe for drivers, since a rigid car doesn't spend any time at all bending, which then leads to a much higher average force felt by the driver. And there you have it. That's how to understand an impulse in physics.